Okay, but listen. When you see ones that you know you're going to get bogged down on, that you know won't be quick, bubble some. Don't just skip it, okay? Bubble something in, guess on it, star it on here, and go back to it. And then you can change. That way, if you don't have time to go back, you've already got something bubbled in. Okay, let's look at part A. Never leave anything blank, because remember what they do. They don't penalize you for wrong answers. You get points for your writing, okay? So don't leave anything blank. And remember your time. You get 1.2 points for it, but they don't deduct points when you make them. Like, you don't get, right, you just don't make them. Some people say, I've never used this strategy. Some people say go through and answer all the ones that you can answer like that and then come back. I don't like that because I lose track of where I am. I'm really OCD about my order. I always go in order. And even on the ones that bog me down, I still go in order. And if I look at the time and I see I'm running, I've got 5 questions left and I've only got 10 minutes left or 7 minutes left, then maybe I might start with that.
I started with 90.
I lose track. All right, so let's go through the Mrs. Non-Calculator just quickly.
Oh, yeah.
What you mean, final exam? Oh, paper. I always choose paper if I can. I didn't know. You're talking about the AP exam. I will never choose a calculus test. There's no way. I don't know how you could do that. Yeah. And the good thing about this test, you can go back on the on the FRQ. I'm going to have to look. One of them you can go back if you have extra time. I can't remember which. I never had extra time. I always used everything. All right, let's look at the first one. The first one asks us to find dy dx, which is a simple derivative. I'm just going to go over. That was product rule. Bless you. Derivative of the first times the second plus the first times derivative of the second. So that was B. If you need me to work it, tell me and I will. Yeah. Number 2. And remember, those simple mistakes are going to be on here. So make sure you're looking at all that. I'm just going through right now. Whenever we hit the halfway point, I know whenever we have to go get a Leo when somebody's alarm goes off, I'll pick up the pace and start skipping around if I need to. Number 2, there's a function. Which of the following intervals is f increasing? I did a sign analysis chart. You have to find the derivative, set it equal to 0, find so you get x squared equals 100. So I got plus or minus 10. I did negative 10 and I did 10. I did sign charts for so many things because in my brain I know that the sign of the derivative tells me a lot about the function itself. Negative, positive, negative, and so I knew that it was increasing here. The derivative there, which would be 300 minus 3x squared. Yes. Because to know where it's increasing or decreasing, these are the kind of questions that test to see, do you understand that the sign of the derivative tells you increasing? Do I need to slow it down a little bit and go over them a little bit slower? I'll be happy to. Okay. And that was probably answers on there. So remember, function, derivative, second derivative, we got the function itself, then the derivative tells increasing, decreasing, the second derivative tells concavity. And all of those we're looking at where it's equal to 0. So that's why I always write this down here, because I can never remember which I'm supposed to plug into. You remember that the derivative is on the bottom. You're plugging into the derivative to see what the sign is, and it's telling me what the function is doing. So you're always plugging back into the derivative. Yeah, quick, right? 3 was even quicker than that. Secant x, tangent x, dx You couldn't forget the C because they all had C's on them, but you just had to know that the antiderivative of secant x is secant x tangent. Good. That was a freebie. That was one of those quick freebies. That's right. Get those for sure. A. Number 4. 4 was a little bit harder, but really not. 7x minus 3 plus log x. It asked you to find the derivative at 1. The first thing I did was found the derivative. I know that the derivative is 7 plus derivative of constant is 0, 1 over x. So just plug 1 in. And it's only right there. 7 plus 1 is 8. That's E. They generally start out kind of easy. They get a little bit harder as we go. Number 5. I told you, you're going to look at some of these and go, oh my gosh, what in the world was I thinking? The function f is shown above. Which of the following statements is false?
Yeah, I got it. I realized it was false. I was like, what? There's like, oh, these are right. Like, what?
So remember, in order, this is testing. Remember we talked about those questions that test your knowledge of the definition. What is the definition of a limit? It's got to be the same from the left and the right. And so there's only one on there that's not the same from the left and the right, and that's at 4. Because that's a discontinuity there, right? Jump discontinuity, which means the limit does not exist there. All right, particle motion number 6. This was a good one. I feel like these problems are way easier than what we did in class as far as the, but it's just velocity of the particle. That's the thing is it's those, that's why multiple choice, that's what students do better on free response most of the time than multiple choice, because you do those little careless things and you lose full credit for the whole problem, you know what I mean? All right, so this is velocity. It asks for total distance traveled.
So we're looking. So what is? So they were looking for position at the end of that, right? That's what you get.
Right. Right.
Yeah. In this class, we will never have to find it. There is one open up. It's called.
Yeah, no, not here.
What is it? You know what I'm talking about?
Yes, yes. It's maybe a multiple choice question randomly in a random year. It's not. It's just third derivative, but I haven't seen that tested. It's rare. All right, so total distance here, again, this was a simple antiderivative, 3t squared minus 1/3 t cubed from 0 to 3. And you get 18. 27 minus 9, which is 18, which is d. See the amount of calculation you'll have to do without a calculator, just so you kind of get used to that on what's expected. All right, number 7, derivative here, that was a chain rule problem. Every one of these, I feel like test a definition is what they're doing. One concept, definition. When you have to do multiple things, that comes more in the FRQ. X cubed minus cosine x to the 5th. So we have to do the 5 around and then derive that inside. 3x squared plus sine x. Now notice we've not spent longer than maybe 30, 45 seconds on a problem yet. I have an itch on my back right there. Okay, 8, yes. I know why y'all got 8 wrong. Did you add the 50 back in on number 8? In the very beginning, the answer is C. If you got A, this is actually one of the ones that I wrote. I don't know if I fixed it before I put it in or not, but I had A circled on here and then erased it and put C. And then I went back and circled contains 50 liters. That happened twice on this test, 2 different problems where they gave you an initial start amount and you had to add that back in whenever you went back to. I don't know if I officially missed this one when I bubbled in or if I missed it, rethought it, and then like before I saw it, you know what I mean? I didn't star this one, so I'm thinking I got it right. All right, so a tank contains 50 liters of oil at 4 hours. Oil is being pumped into the tank at the rate of the. Okay, so we have this chart 4, 7, 12, 15. Lizzie said in depth here. Okay, so all Riemann sums are rectangles, right? All right, so here's rectangle 1. And I have this over my table. I've got 3. Didn't it tell me 3? Okay. Right, that's 3 rectangles.
Okay, yeah, I think you can write it.
Okay, so I do. All right, so the first thing I do is from here to here, this is, what is that, 0.3? Right? What is that one? They're all 0.3. What did I do?
You know, y'all always try to tell me C's not the best one. Dylan, B's the best one. B's the best test. So, you know, C's the best test.
No, this is not the difference I need. That's why I'm confusing myself. This is your X and this is your Y. Think about it on a graph, right? I need the difference of the X's. Now I need the height, and that's where the Y is going to come in. The Y is my height. Sorry. Yeah, I did it on the test. That's your width of each rectangle. These are not equal width because when you're on a table, they're not necessarily equal. So I've got rectangle 1 that's got a width of 3. I've got rectangle 2 that's got a width of 5, and I've got rectangle 3 that's got a width of 3. Now I need the height. So if you think about if I've got this point 4, 6.5, 7, 6.2, right? And I'm making a rectangle between the two. It said a right Riemann sum. I'm going from the right side here, right? So what's the height of my rectangle? 6.2. And I use all the right values. So there's the 3 rectangles. That gives me that area, but here's the problem. If you multiply those and add them all 3 up, you get 64.9, which seems like a valid answer, right? But then I look, so 3 times, well, that was my thought. That's what I just looked and went, that's the lowest one. I'm thinking I need to check that. 3 times 6.2 would be 18 point, and this is one. Look what you have to do without a calculator here, right? Look, I've got little. I'm finding the area of each rectangle and then adding it together. Okay, because that's the area under the curve using rectangles. 5 times 5.9. What is that? 29 point, nope, yep, 29.5. And then add all 3 of those together. And you get 4.9, which is answer A. But if you go back and reread the question, a tank contains 50 liters of oil at time t equals 4 hours. You're going from 4 to 15 hours, and it's asking you how much total oil is in the tank. Well, all you did was found how much went into the tank between hours 4 and 15, but it's asking you in total, so you have to add that 50 back in there. So you have to understand what it is you're finding. So the answer is 114.9, just C. I felt like that was a tricky question because of that. So read those kind of questions very carefully because that happened again. Don't skip that because it's too easy. Riemann sum is too easy. Come on.
Well, it is now. Like when I saw it at first, I was like, I can't remember. Yeah. They've got the same decimal.
All right, so can everybody in here do a Riemann sum from a table now? Y'all remember? Yeah, remember we found the midpoint between the two, and then we had to plug it into the function. Wouldn't be on a table. Yeah. Okay. 11, let f of x be defined by the square root of the absolute value of x minus 2. which of the following is true? I knew that was a corner or cusp kind of problem, and so I knew that it would be continuous. Did I skip? Oh my gosh, I'm sorry. Okay, well, just to finish talking about this one, there was a cusp that looks kind of like this when zero's under here. A, it's continuous but not differentiable. So that's just making sure that you knew.
I need you to get up to this. I need you to go over. Yeah.
Okay. Okay. This one was not because it was a corner, like a cusp, not a corner cusp.
What happens at cusp?
No, this is a pretty frequent function. Have I not been recording? Differentiable there. We know it is continuous. I mean, there's a point there that continues on. Couldn't be a vertical asymptote because you don't have a denominator. And what is that? The limit as x approaches 2 of f of x does not equal 0, but we know it does because it hasn't had any vertical shift. All right, backwards, sorry, I didn't mean to do that. On number 9. Ooh, this was a good one. Hello, Luke. Would you like to do a continuity problem with us? Let f be the function defined above for what value of k is f continuous. So this is just testing, do you understand what continuity means? So can we plug in? Yeah, we'll see. Let me know how that works out for you, buddy. But, okay, so for what values of k, so all I did was I did this, right?
I did that too, and I was like,
If I then, so this said when x is not 2, so now if I take this 2 once that's gone and plug it in, how do I plug the hole? 2 times 2 is 4 plus 1 is 5, so it's e. Okay, so this is when, remember when we were doing algebraic manipulation? Did you say I killed a kitten? Because you can mark things out as long as the plus or minus is enclosed in parentheses. So yes, I'm subtracting. God, you know what? My goal for the end of this class is that you never kill another kitten.
well, I don't. It's like stuff like that. Like in my head, I was like, I started to do that. I remember that, and I was like, oh wait, I want to.
So entire things you can't. But even if you had done that, Dylan, if you had said 2x plus 1 over x minus 2 times x minus 2 over x minus 2, well, that's 1. Anything times itself. Oh, no, that still wouldn't work. Never mind. You can't split up multiplication. I'm an idiot. That would be if you're adding. No. Yeah. Okay. Does that make sense? Plug the hole. That was just a plug the hole problem. And it was already factored for you. Most of the time, they're going to give this to you as a polynomial, and you have to factor it yourself and then cancel out. Does that make sense? I know, that's what I told you. But as you do more of them, your exposure to them, you start to see the pattern in them, and it becomes easier. That's my goal anyway. Is that by the end of the class,
I'm like, I feel like I should know how to do this.
I would say nobody else wanted it. Okay, so 10 took me a significant amount of work. I had to do a U sub on 10. Okay, so the first thing I did was I used my knowledge of what an E function looks like, and I wasn't real sure where or what happened, right? But somewhere I've got this exponential growth problem is what I've essentially got. And it asked me the line x equals 2. What's the area of the region in the first quadrant bounded by the graph of that and the line x equals 2? So I literally, if I put 0 in here, oops. This is really, because I don't know what this graph looks like, so this is how I reason through it. If I put 0 in here, which 0 would be where it's at the x-axis, right? I get e to the 0, which is 1. So I know that this point is 0, 1, right? I know that this point is 2. Well, what is e to the 2 over 2? Just e, and I'm going to leave it just e. So I know I need to find the integral from 0 to 2 of e to the x over 2 dx. I let my u, any ideas? So that would mean du is 1/2 dx. So I need a 2 out here because I need a 1/2 in here, right? Yes, you're absolutely going to have to change the bounds here. So if I change this, I got 2 e to the u du. I'm going to have to change these bounds in terms of u also. So u of 0 is 0, u of 2 is 1. So it actually makes a little bit easier bounds. Now I have 2 times e to the u evaluated from 0 to 1, which is 2. Sorry. Which is 2e minus, which is letter A.
Oh, yeah.
I guessed it right.
That was so clean. That was really clean.
What does that mean? I thought that one was kind of difficult because it was a U sub, you had to adjust the bounds, and they didn't just give you it wasn't a straightforward question, you had to understand the info. I thought that was a kind of tough question. Okay, when you see area of the region, you should automatically think integral. Okay, when you do integral, I don't know what the antiderivative of e to the x over 2 is. That's when I think, oh, that'd be rough. We did 11. Number 12 was, 12 told you it was U sub. They gave you the U to use. I thought it was very, very straightforward and easy. You did, okay, so let's look at it. If u is the square root of x, and you've got this integral of 1 to 4 e to the square root of x over square root of x dx. All you have to do is get the integral set up. So this is a lot like the prior problem, but not quite as much work. So if u is the square root of x, what is du? 1/2 x to the negative 1/2, right? Notice that I have an x to the negative 1/2 already in the problem. The only thing I'm missing is this 1/2. So if I need a 1/2 hooked to the dx here, I forgot the dx, then I need a 2 on the outside. So now I have 2 times the integral. I'm not going to put my bounds because I'm going to have to redo my bounds in terms of u. E to the u du. And now u of 1 and u of 4, it's just the square root. Well, it's du is 1/2 x to the negative 1/2. So the 1/2 I countered with the 2 outside. If I have 1 over the square root of x, that's the same thing as x to the negative 1/2. So this is the same thing as 1/2. So it's already there. See. Okay.
Susan, you have 9 minutes.
I'd ask them to y'all get down, and now we're just going to find out who's not going to.
What's the next time? That's news to hit different sometimes. I'll be getting back into my dream. This will happen for real for me. I looked at 5 o'clock and was like, my dreams sometimes don't want to happen until right before I got over stuff. But I've been like, get this part where I can try to control what's going on. Like, try to get. I did that and I like took some. Wait, somebody listen to loud music for 8 hours? Afraid of? Repeat same song. I'm gonna do that. You gotta consider if you work out in the dormer, things that are affected that self. I think it's gonna
Okay, we better.
well, well, we just did that one, so let's move on to.
16.
Yeah, I literally need like all of it.
Y'all understood 13?
No, I'll just. I didn't.
Bless you. No, we gotta do F. 2x minus 1. So this was just, did you understand that you could split the integral up? X is greater than or equal to 3. So I did from 1, because it asked you from 1 to 5, right? So I did from 1 to 3, because that would use this function. And then from 3 to 5,
We wanted to, I needed like that. We wanted to, right? Now because
it's x, your x value. But you're picking up from that value. So think about area under the curve. So you're going up to 3 and stopping. That doesn't matter for the integral. That doesn't matter if you split the integral up. If you only took this up to 2, then did you start this at 2.999999999? I mean, you see what I'm saying? So you'd be missing area under the curve. So you take it up to that point. And so this would, of course, be 2. This one would be x minus 1, and then there's straight up antiderivatives. 4 for the first. This area would be 4. This one would be 6. Well, but then you have to find the antiderivative, right? So this would be 2x. Well, which one goes from 1 to 3? This is when x is less than 3. This one when x is bigger than 3. So I had to split it up into 2. I can't just straightforward find this integral because f is different as I go through this interval. This is from 1 to 3. And then this would be 1/2 x squared minus x, and this one goes from 3 to 5.
The antiderivative is one of them, and it's the derivative of the 2.
10. C. Okay, so 14. I probably went about this the long way, but I think that the way that I went about it, you'll understand it better. So I think that that's how I'm doing. All right. This one did take me a little bit. The answer was A. So if f of x is the square root of x squared minus 4, and g of x, Aaliyah, by the way, said that first part was really easy. She felt like it was kind of easy. Did y'all feel like that when you got done?
I feel like it should.
So we want the derivative of this. You felt like what? Did you? Good. I hope it feels. Yeah. All right, this was a chain rule problem again. The derivative of f, and then I have to do the derivative of the inside. This is just saying if you have a function, like a compound function, you have to do the derivative of the outside and then chain rule it for the derivative. That is all that's asking you. And so then it becomes easy because the derivative here is 3. The derivative here, 1/2 x squared minus 4 to the negative 1/2 chain rule times 2. And I'm putting in a 3 here and a 3 here because it said at x equals 3. Well, this just becomes 3, right? This one, regular g of 3. 3 times 3 is 9, minus 2 is 7. So now I need f prime of 7. This was a lot of calculation. I felt like that was the hardest part here. The derivative at 7 is 1/2 times 49 minus 4. 49 minus 4 is 45. Negative 1/2, I lost my place, times 2 times 7. I canceled those 2's out here. I got 7 over the square root of 45. I got to times it by this 3. So 21 over root 45. I did, well, that's what I was going to say. I did check to see here if that answer was on there, and it was not. So I do, you're exactly right. I got to simplify that radical. 9 and 5. So 21 over 3 root 5, which would be 7 over root 5. Didn't have to rationalize it, but that was there. That was part A. There's where all that algebra 2 stuff just blah. When you don't have a calculator, you can't tell which one's the decimal equivalent. So, all right, 15. The graph of f. This is just like that FRQ we did last week. I have to realize that f is the derivative of h. It's a. So my reasoning for this is what I wrote on this. And I really do work these blind and try so I can think through where y'all might stumble and run into problems. I said, what would h6 of be? What would the derivative of 6 be? And what would the second derivative of 6 be? Knowing that the graph that I'm looking at is this graph. Okay? So at 6, I know I can look on the graph, that's 0. Right? Okay, so let's look. Okay, so what is the derivative there? So the derivative is the slope, and that's going to be positive, right? So I said, well, I don't know what it is, but I know it's bigger than 0. What is, now go backwards on it. So going backwards, I'm talking about integrals, so I'm talking about area. That area is under the x-axis. It says h of x is equal to the integral of f of x, which means the derivative of this is the graph that I'm looking at. So now if I go backwards and integrate, I'm talking about area, it's under the x-axis. Under the x-axis would be a negative value for the integral. I know it's 0, so I know that I'm going that this is the smallest and this is the biggest. Because it's negative. It's the only one that would have a negative value. Because it's under the area is under the, like, I mean, and I wrote, so I shaded it in and I said, okay, this is h of x because it goes, because even if I came here and said h of x equals the integral from 6 to 0 of f of t. Well, from 0 to 6 here, that's negative, so that's h of x. I put here, second derivative, that's the slope up here. That's a positive slope. And then I know that point right there is 0. The second derivative would be the slope of this because this is the derivative. You're given the middle one. And you got to go backwards and forwards. You got to go integral and derivative. Correct. So this is slope. This is area. All right, 16. A particle moves along the x-axis. I love these kind of problems. I know I'm weird. Where A and B are constants and A, but usually when they give you variables, it's not a really hard solve because it's so conceptual. So don't get caught up so much in it. All right, which of the following values of t is the particle at rest? Well, at rest means what? What equals 0? Velocity equals 0. So if I want to find velocity, well, I'm going to go through here and I'm going to I actually FOILed this out because I found it easier. T squared minus BT minus AB plus AB. And I want to know the derivative of this. Remember, it's derivative with respect to t, so everything else is just a value. So the derivative, which is velocity, 2t minus, oh, this is at minus a. Where does that equal 0? And I got here and stopped and went, crap. But then if you look at the way the answers are written, they all have a and b in the answers. So solve that for t. Add a and b and divide by 2. It's b. You don't like that question? I like that question. Again, are y'all seeing a theme here with these graphs? And you have to determine, is it the graph of the derivative or is it the graph of the function?
I got a slew of wrong ones.
All right, so again, this is the graph of the derivative of g, okay? So what does the derivative graph look like here if you take the derivative? Well, if it's just a line with a constant slope, then the derivative graph is going to look like a constant, right? But I have to decide, is it A or is it B? Is it above the graph or below the graph? Well, is the slope positive or negative? Positive slope, so it's a positive constant, which is A. 18. Oh, 18. If you did not recognize that being the definition of a derivative, which would be the derivative of the log of, remember it's f of x minus, it's f of x minus h. Lord, I can't even remember now. Plus h minus f of x over h. Okay, so if you did the derivative, because you looked at L'Hopital's, if you plugged it in, if you looked, and that's actually because I had a brain fart on here whenever I first saw it and did not even recognize it being the definition of a derivative until I flipped right just now, honestly. But it is an indeterminate form if you try to evaluate the limit. So you could do the derivative of the top over the derivative of the bottom. And, well, I did, okay, so I said, this is how I did it. Over h. I split this one, Dylan, you can split. Log of 4 plus h over h minus log of 4 over h. Right, this is indeterminate. So I did the derivative of each one. So the derivative of this is what? Over derivative of h is 1 minus, this is a constant, derivative of a constant is 0. So now can you plug 0 in here? Yes, you plug 0 in for h and you get 1/4. If you did not do that, you could have recognized here that f of x is log of x, and you are asked to find the derivative at x equals, you're asked to find f prime of 4. Because this, remember, it's f of x plus h minus f of x over h, and this is the limit as x approaches, h approaches. Yes, this was 2012's.
I feel like I was kind of close to it. I had to guess
We got to start working on time management for them. Now remember, you were shaved 5 minutes, I think, essentially. Maybe 10 minutes, I'll have to look, but yeah. All right, 19, the function f is defined by f of x equals x over blah. Do y'all need this one? Okay. What points x, y on the graph f have the property that the line tangent? As we got further, y'all missed a lot of them. we'll probably have to work them all. And we might have to come back to some of the calculator ones next week. What points XY on the graph? No, we got to take it on Friday. That's FRQ. No, because you got to get the practice on both.
But I mean,
We're doing.
I want to be like able to review it.
We will, but you won't have multiple choice this week. This week's FRQ. So before you take your next multiple choice, I will have gone over all these. No, we do FRQ practice tomorrow, and then we do the FRQ portion of another random practice test. More excited? No. He's got that look down. Okay. What points have the property that the line tangent to f at xy has the slope 1/2? So essentially, remember, slope is tangent. So if I find the derivative, I am just going to set it equal to 1/2. I'm going to find those points, and then I'm going to plug them back in to find the y value.
You know, one second, I know what you're saying. You don't know what you're saying. That really does help.
I'm telling you, at some point, you'll have to take a derivative. All right, so if I find f prime, here's your quotient. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom square. I need to know where this equals 1/2, so I had to multiply this out. I got the x's cancel, 2 minus 1, right? Oh no, just 2. So right, you have 2 over, FOILed this out, x squared plus 4x plus 4. Cross multiplied, 4 equals x squared. Here's your, this is straight up algebra 2. Where does x squared plus 4x equal 0? At x equals 0 and x equals -4. That I know. And there's only one that have those two x values. You didn't even have to plug them back in, so C. Did you guess? All right, 20. Oh, I bet y'all do need 20.
This is where my
G is the inverse of f. Given that f of 0 equals 1, what's the value? I didn't even use that f of 0 equals 1. I found it easier to go through and first find g of x. Well, how do you find an inverse? You switch x and y, and you solve for y. Cubed root minus 1 divided by 2, right? Cubed root minus 1 all over 2. This is g of x because that is the inverse. Switch x and y and solve for y. So cubed root both sides. Then I subtracted the 1 and then I divided by 2. Okay, but it asked me to find g prime of 1. So I need to find, well, what's the first derivative of g? Again, with the, well, I split this up, and I'm not killing a kitten, Dylan, so that I could take the derivative. Well, this is 1/2 x to the 1/3 minus 1/2. So multiply, so I get 1 over 6 x to the negative 2/3, right? And you just plug in 1. Remember, you don't have a calculator, so if you get something funky, something's going wrong because you have to be able to do it on your own without a calculator. So this would be 1/6 because 1 that anything is 1. All right, number 21. Yeah, because it asks you to find the derivative at 1. If you do it this way, which I feel like is the easier way, yes. The line y equals 5 is a horizontal asymptote to the graph of which function? This is where you're looking, Katie. This is what we were talking about the other day. Top heavy, bottom heavy, same. So look at the degree of the top and the degree of the bottom. And that would be the very first thing I do is I look to see if I'm in a situation of a horizontal asymptote. Remember, vertical asymptotes happen when I am bottom heavy. Horizontal asymptotes are whenever I have the same degree and I have to take the leading coefficient of both of them to find the asymptote. Y'all remember that? So, all right, so top heavy, there's no asymptote. Okay? Bottom heavy, y equals 0 is the asymptote. And if the degrees are the same, then you take the leading coefficient of the top divided by the leading coefficient of the bottom. So E, because look at leading coefficients hooked with the degree, 20 over 4, which is 5. No. And if I get confused, I think about a basic example. If I have x cubed over x, well, that's just going to simplify to x squared. There's no asymptote there. But if I was x over x cubed, well, that would be 1 over x squared, and I can't have a 0 in the bottom. And that's, okay, so think about, remember that parent function 1 over x that looks like this? I always remember that that has an asymptote at y equals 0. So anytime I'm bottom heavy, y equals 0. I think these are on those colored sheets I ran you, but I'm not sure. You're only looking at horizontal. Vertical come in when you set the bottom to 0. Horizontal is only top heavy, bottom heavy, same. Okay, so bottom heavy is y equals 0. Top heavy is none. No asymptote. These are just horizontal asymptotes, not vertical. And then the same, which is the situation that we have here, it's y equals leading coefficient of the top divided by leading coefficient of the bottom. So in this case, 20 divided by 4 is 5. And so y equals 5 is my asymptote. That was a straight up algebra 2 problem there. Maybe a little bit of pre-cal. We get into it a little more in pre-cal, which y'all unfortunately did not get. All right, 22. Absolute maximum of f. I did another sign chart here because I'm a sign chart freak. I do. They help me understand. Here's my f of x. If I want to know maxes and mins, I'm looking at what am I looking at to find maxes and mins? I'm looking at, that's exactly right. Find when the derivative is 0, find the sign and see what they're doing. So the derivative here, root of the top times the bottom minus the top times root of the bottom all over bottom squared. Where does the 0 equal? Well, remember those quick ones that we went through? So these, I'm sorry. Yeah. 1 minus log x over x squared. I'm not worried about where the bottom equals 0. That's going to be an undefined point. I'm looking at where does the top equal 0 to make this fraction 0. So 1 minus log x equals 0. So where does this happen? At e. Change the form there, right? E to the first equals x. So at x equals e. So I have my sign chart. It can't go less than 0 because you can't take the log of a negative number. So I have a domain restriction there. This is e. Remember, I have to do this every time, so I remember what am I looking for. If you plug in a number, let's say 1 into the derivative equation, here is my cleaned up derivative equation. The log of 1 is 0, so it's 1 over 1, so it's positive. So it's increasing. All I need to do is make sure that this is negative, which is decreasing, and it does because this is going to be bigger than 1 whenever I plug in something bigger. So what's your absolute? Look, what's the question saying? We talked about this on a test.
The absolute maximum of the function.
Value of the function. Not the x value, the value of the function. And whenever it says value of the function, plugging back in. So what is f of 3? E. So log e over e, 1 over e, or e to the negative 1, but either way it's b. Go back into the original f of x and put an e in there for the x. Because it says value. When I read this, I have it circled. I circled value because I knew I was going to forget and try to do. And I'm surprised the x value is not one of the options on it because it usually is. 23 was a quick give me question. If P of t is the size of a population at time t, which of the following differential equations, so I've taken the derivative of something, the differential equation describes linear growth in the size of the population? What's the derivative of a linear? It's a constant. There's only one constant on there. It's a. Which of the following differential equations, so if it's a differential equation, I've already taken the derivative. So which of the following is a differential equation of a linear growth? I know. I hope it's A. I hope what you're seeing is you could have done a lot better than what you did had you read the question carefully.
Well, I came in that Friday and I was like,
the non-calculator is a lot easier than the calculator. It does. Some of them take. That's why we got to. Whenever you actually do it, it'll be time. Oh yeah, like I'll go to the store. I'll ask y'all what kind of snacks and stuff you like. I'll go buy y'all some stuff that you'll have. I'll probably bring you breakfast before too. That's what I did last year. And then you'll have a break in between where you can have snacks and stuff. Well, y'all should have thanked him because we have to pay for that. Oh, y'all brought it. Yeah. But yeah, in the middle you have a break. You have a time to walk around and leave. And I taught him.
He was like facing a light. He was standing on a chair.
Alex!
The bald guy.
Okay, you're talking about the guy that cooks and manages. You're not talking about the owner. Alex owns it.
Alex who?
Singleton? Mm-hmm. 24. Let G be the function given by where K is a constant. For what value of K does G have a critical point X equals 2/3? This one involved a lot of work for me. So G of X, if I need to know a critical points happen where the derivative equals 0. So we need to find the derivative. Product rule, derivative of the first times the second, plus the first times derivative of the second, e to the kx, but I have the chain rule here. So times k, because the derivative of kx is k. So where does this equal, is that what it says? Where does it equal 0? When x equals 2/3. So I'm going to plug in 2/3 for my x's here. Actually, let me clean this up just a little bit first. Just because I'm so used to doing algebra 2, I always try to factor if I can, especially if I'm solving and equaling to 0 and whatnot. And whenever I did this, I noticed this was the same for both of them, and they also both had an x. So I took out an x e to the kx. I wasn't sure if it was going to help me or not just yet, but I did it, and it did end up helping me some. Now I got two things multiplied together to give me 0. So I set each one to 0. Remember, I'm trying to find this value of k but they gave me a little more information than that. They also gave me x. So x was 2/3. So 2/3 and 2/3. 2/3. Now I'm going to solve for k. Oops, it shouldn't be. It should just be x, sorry. All right. Here, divide. Will e to the 2k over 3, that's never going to be 0. You can't raise e to anything and get 0. There's an asymptote there. Think about your growth. That's never going to happen. It's not going to impact my answer. So now I'm just focused on this little piece over here. So I subtract 2, multiply by the reciprocal, negative 6 over 2, 2's cancel, so negative 3, which is 8. Yeah. I'm telling you, I fly through these more on my algebra skills than on my calculus skills. That is, but seriously, I mean, the same thing happened. I remember going through, because I've taught Algebra 2 for so long. I mean, my algebra skills are so grounded. That's where your trouble comes in, is your algebra skills, for sure. All right, 25. Which of the following is the solution to the differential equation dy dx? So, oh, we finally have a diffie Q. A what? $68. All right, so again, I am going to split up here. So dy equals 2 sine x dx, and I'm going to integrate both sides. So I have y equals, the antiderivative of sine x is what? So I got negative 2, because that 2 can come out. Cosine x, do not forget the plus c. The plus c is there. This is why we have an initial condition. Y of pi equals 1. I'm sure y'all love that. 1 equals negative 2 cosine pi plus c. What's the cosine of pi? So it's e. I know. I'm going to run through these quickly to try to get through. You've got the derivative equal to 0 to x e negative t squared dt. I did sign charts again. I'm sure y'all are very surprised by that. Yes, yes. But you really don't, so you understand that g of x, no. The second derivative here would be e to the negative x squared. Going backwards, it's a. Because if I plug in x for that, from 0 to x, if I do derivatives on both sides, I literally have 2 sign charts, and I said first derivative tells me what it's doing. This is increasing, decreasing. Second derivative tells me concavity. And I plugged in, if you plug in here, you'll find that it's always positive, and increasing here is always positive. So it's always concave up. This is the second derivative. This is the first derivative. And then backwards even more from that. What did I do? No. That gives you the first and second. All right.